There's a couple ways of approaching this. Which points belong to the solution of this inequality? Well, you can go ahead and plug a whole bunch of points in, but that would be just a pain in the neck. So I would suggest graphing this. You've got your y-intercept and your slope, easily identified over here. I'm going to write the equation so we can see them both. 1/2 x minus 1. So then minus 1 is our y-intercept. Our slope is up 1 and over 2, and so if we can kind of continue that trend and continue this trend, that's a point, that's important. This says less than, which means it's a dotted line. So do we want to include A in our solution set? Well, I'm glad you asked. We'll have to get back to that. Don't interrupt. Y is less than. That means we're shading this direction, okay? So anything in the shaded region is part of our solution set. That includes G, B, and H. G, B, and H. Now you may have noticed that I did not include A in my solution set. That's the point of the dotted line. Dotted line means everything below this line is what I want to include. But because it's a dotted line, I don't want to include anything on the line. So A being on the line still does not make it something we want to include in that set. Okay, so it's just the G, B, and the H. Proving algebraically why that's not part of the solution set, and if you didn't get that before, then here's your opportunity to actually see. If we're going to identify that point, 1, 2, 3, 4, it's a -4 and then a -3. A is at -4, -3. And if I were to plug those things into this equation, you're going to go -3 in for y. You want to see if that's in fact less than 1/2 of -4 minus 1. Well, what is half of -4? Woohoo! Wow! And there's more. Woohoo! More. Pardon me, I'm just going to leave that though. It's easier than stopping the video. -1. Okay. Now I've got a -3 is now less than. Now, is that true? Well, not entirely untrue, you might say, but in fact it is. -3 is not less than -3. -3 is equal to -3. There's your algebraic proof. They are not less than, they are in fact equal to, and therefore, since it's an arrow only without a line, it is not true.